Okay, cheer! And here at Keysight Oscilloscopes headquarters in Colorado Springs, we are partying. We're partying for two reasons. The first reason we are partying is because it is the first day of Scope Month. We know you're excited. We are obviously quite excited. The other reason we are partying is we are launching a brand new Keysight Oscilloscope 1000X series scope and a brand new probe to go with that. So we have a whole party going on here in Colorado Springs. It's a good day to be here. So before we start digging into the scope into Scope Month, I thought it'd be a good idea for us to cover the agenda of what we're going to be talking about in the video today. So first, we'll talk briefly about the sweepstakes, the giveaway, because we're giving away a bunch of scopes, and I know you guys are excited for that. After that, we'll dig in a little bit on the high-level highlights of the 1000X series. After that, we're going to dig into some of the other activities we have going on as part of Scope Month. Then we are going to do some more advanced demos. We're going to dig deep into the 1000X. The team is lining up here off camera because there are some things they want to show you, things they love about the new 1000X series scope. After that, we'll be giving away a bunch of scopes, and then we're going to do some live Q&A at the end of the video. So if you type your comments in chat, I have someone off screen here who will be monitoring those comments, and we'll do some live QA at the end of the video. So a brief overview of the Scope Month 2017 giveaway. We are going to be giving away 5 1000X series scopes every weekday in March. And every Friday, we're going to be giving away 2 1 gigahertz 4000X series scopes. So if you go to scopemonth.com, we'll get the URL on the screen. If you go to scopemonth.com, you can enter once per day, once per 24-hour period, resetting at midnight Colorado Springs time, so Mountain Standard Time. If you go to that and you get your entry in for the day before I do the drawing at the end of this video, you'll be entered in today's drawing. Come back every day. We'll be drawing winners live on YouTube. And we'll also be live on YouTube every Monday. So we're live today, and then each of the Mondays in March, we're going to be live so we can do some more QA. We can have some more live demos. And so tune back in. You can actually go to the YouTube page, get reminders for each of those 4 live casts. Also, about the sweepstakes and Scope Month as a whole, on scopemonth.com, let's take a look at my computer real quick. There's an FAQ page here at the bottom. So before you ask any questions, check that FAQ page on scopemonth.com. We're going to be updating that in real time throughout the month. So as we get common questions, we'll address them in the daily videos, but we'll also put them on the Q&A or the frequently asked questions page. So let's talk a little bit about our brand new 1000X series scope. It's a 50 megahertz to 100 megahertz bandwidth scope. There's a DSOX model and an EDU model. So, and the G means it comes with a built-in waveform generator, which we'll talk about later. Sample rate goes up to 2 gigasamples a second. But the thing that we're really excited about is it uses the same MegaZoom 4 ASIC that we have in all of the other Infinivision scopes. So the 2000X, 3000X, 4000X, 6000X, all run on the same ASIC and now the 1000X. So that snappiness and responsiveness that you get in the UI, you get on the 1000X, and some of those advanced features and measurements that you would normally have on a higher end scope, we've brought down into the 1000X. It's also a 6-in-1 tool. We've integrated a bunch of other things into it, and we're going to talk about a few of those. So let's talk about the other Scope Month activities that we have going on, and then we'll dig a little more into the 1000X. So if you don't want to leave your new scope up to chance, you can check out the Test to Impress contest. It's on scopemonth.com. There's a link there. And you can go to that page and submit a video that's less than 3 minutes and tell us why you think you should be the one who gets a new oscilloscope. We're going to be giving a fully loaded 6 gigahertz 6000X series scope, and 2 runner-up prizes will be 350 megahertz 3000T scopes. So we're giving away some pretty nice scopes. If you don't want to hope to win a scope and you want to you think you deserve one, let us know. Instead of voting and doing social voting like we did last year, we're actually going to have a panel of judges decide who gets to do that. And the panel is people I think you probably know. So we're going to have Dave Jones on the panel from the EEV blog. We'll have Chris Kamel from Contextual Electronics and from the Amp Hour podcast. And we'll also have Mehdi Sadigar from Electro Boom and myself. So 4 people on the panel. We will decide the grand prize 6000X and the 2 runner-up prizes for the 3000T. So people you trust, we're not doing voting this year. We'll have a panel. That video has to be 3 minutes in length. There's more information on that on scopemonth.com under the Test to Impress contest. The other thing that we have going on is a little fun. I need a prop for this one. We are going to do a Find Daniel contest. So you actually can all collaborate, and we'll add more 1000X series scopes into the pool. So I've hidden 4 of these Daniel cutouts. These are some good looking cutouts. We've hid 4 of these around the world, and we will be releasing clues each Monday on either our Facebook page and or our YouTube channel. And if you are able to find the cutout, and by find the cutout, I mean you take a picture and upload it to our social media using the hashtag #GoFindDaniel. If you can find these cutouts and upload a picture, we're going to add more 1000X series scopes to the pool. So we'll announce clues on Monday. If you find the cutout by Tuesday at midnight, so 11:59 p.m., basically midnight, we'll add 5 more 1000X scopes to the pool for that week. If you find it by Wednesday, we'll add 4. Thursday, we'll add 3, Friday 2, and Saturday 1. So the sooner you guys collectively find the cutout of me, we will add more scopes to the pool. So by collaborating together, you can all increase everybody's chances of winning. There's a link on scopemonth.com to the Find Daniel blog post that has some more details. You can also use the comment section of that forum to collaborate, or if you find some other way to collaborate where people are trying to work out these clues, let me know and we'll make sure that everyone's on the right track. So that's the other main activity we have going on as part of Scope Month. One last thing, if any of you are watching from Australia, we have a special contest going on for Australia. You can thank Dave Jones, who lobbied us really hard to get that contest happening. There's more details on the Australia localized page. So if you're in Australia, you're eligible. If you're not, you are still eligible for the overall Scope Month contest. So let's look a little more at the 1000X. The team is lined up here and they have some things that they just love about the 1000X that they want to show off. So up first we have Ali. So Ali, come on out. And Ali, what are you going to show us today?
So I'm really excited to show you one of my favorite things about the new 1000X, which is training signals that are actually built right into the scope. So these are great if you're a beginner to scopes and you just need to get oriented, or maybe if you just need to practice using some of the more advanced tools in the scope. So the best part is these are actually live signals. It's not memory or anything. So these are coming straight out of your scope, and all you need to use them is just a probe. So you plug that in, get it hooked up here, and then you can just press the help menu.
Those are actually connected. They're coming out of the probe comp port. So it says demo on there. It's also the probe compensation port. We're routing live signals through those things.
Yeah. So you'll hit the help button here, and then you'll see training signals. And you'll click that, and you can actually just scroll through all of the different training signals that are available. So maybe you want to look at peak detect and understand how that works. So maybe you'll look at sign with a glitch. See if we can get that on screen here. So that will just give you an opportunity to kind of practice using that and see what it's like on your scope. Another one, maybe you want to look at segmented memory. So you could pull up like an RF burst and check out that and practice using that. So overall, it's just a really great way to get oriented with your scope and just practice using it before you show it off to your coworkers or use it in your lab, whatever you need to do. It's just a great training tool.
Awesome, thanks Ali.
Yeah, no problem.
So we actually get a lot of people requesting to have those features turned on in their other scopes so they can show off their new scope to their coworkers. So it's now built-in standard onto the 1000X. It comes with every single scope. Up next we have Johnny Hancock. You probably remember Johnny from some of his other videos on our YouTube channel. What are you going to talk about today, Johnny?
I'm going to talk about the new frequency response analyzer. It's basically free in this oscilloscope if you get the waveform generator. And if you're not familiar with what an FRA or frequency response analyzer is, sometimes they're called network analyzers. They plot gain and phase versus frequency. Now gain is basically, is computed V out over V in, 20 log V out over V in, and we provide the plots. So
this is actually, I'm going to interrupt you real quick, Johnny, if we can come back out. This is actually Johnny's brainchild. So if you like this feature, you can thank Johnny and the R&D team for getting this implemented. So Johnny is a big proponent of making it happen. You might have seen his webcast. I think on our YouTube channel we have that webcast recorded with Johnny making frequency response analysis measurements.
And we have another one coming up in a couple weeks.
Yeah, check it out. We'll put a link for that in the live cast. So Johnny, I'll let you get back to it.
Okay, so this should be the dream of every electrical engineering college student. they're still making frequency response measurements just like I did 40 years ago, where you measure V in and V out and then compute 20 log over V in, measure the delay. This does it all automatically. And I would hope it'd be a dream of college professors as well. So anyway, what I have here is a small passive RLC filter. It creates a bandpass filter. I've already connected the probes to V in and V out, and I'm going to connect the input to the output of the WaveGen. I'll start with the default setup. Then I'm going to use the Analyze menu, and then that's where we have mass test, digital voltmeter, and that's where you can find frequency response analyzer. I'll select that. Next, to set it up, let's just select, well, I'm used to our touch screens. Setup gives you a diagram showing you how you should connect things. But what you can do is which channel is input, which channel is output. We can use the defaults. Minimum sweep frequency, right now it's at 100 hertz. I'm going to turn that down to the minimum 20 hertz. Maximum 20 megahertz. And then test amplitude. We'll just use the default. It's sit here at 200 millivolts per division. Press back, and then just press run analysis. And so you can, and something's not working, and there, let's abort this because my probe wasn't connected well. Well, it's not touchscreen.
Thwarted by the probes, Johnny.
All right, let's try that again. There we go. You can see V in is the yellow waveform, V out is the green waveform. It's very, very low level. This is less than 10 millivolts. It's basically down there very close to the noise floor. I'm using the 10-to-1 settings on the probe. I might get a better response if I was using the 1-to-1 setting to measure those very, very low level signals. You can see it's stepping across in frequency. It's always rescaling in time base, so it looks like the same frequency, but it's changing the time base as well. You can see the blue trace. And by the way, it looks like I have my probes connected backwards, so they're inverted. So this looks like the inverse of a bandpass filter. When you do live things can get backwards. So the blue is the gain, and it's showing just the opposite of what it should. The orange is the phase. At this point, I could move the markers and measure gain and phase. The readout is down here at any frequency. You could rescale it, although it does automatically scale as it's making the measurement and gives you optimum scaling at the end of the measurement. So, anything else, Daniel?
That was pretty comprehensive. Thank you, Johnny.
Thank you.
So we are really excited about the FRA feature. We've had tons and tons of people in our early discussions with them get really, really excited about this. So if you put this to an interesting use, I want to see it. Let me know. You can talk to me on Twitter. Who's next? You can come on out. So you can let me know on Twitter or our Facebook page, YouTube channel, and you can come right up here next to the scope. You guys know Mike. We colloquially have dubbed him Hoftron 9000. So Mike, what are you going to show us on the 1000?
Well, first I'd like to say hi to all the commenters. Yes, Daniel really is this tall. So to answer your question, he is a very tall person. But what I was hoping to show you today is some of the serial decode capabilities of the 1000X. So I am going to see if I can figure out which probe is which.
Well, Johnny left his board on.
You did.
That was crafty, Johnny.
You did.
Oh.
Well, I need that probe to hit. The witch hat came right off. There we go.
Alrighty.
All right.
It's always good to start with the default setup.
It is. Okay, so there's a number of different, here we go. So there's a number of different serial buses supported by the 1000X series. But for the sake of simplicity, I'm going to show us a single line bus. It's got an embedded clock in it. Makes it just real easy to show here. Let's go ahead and auto scale. So just like the rest of our Infinivision X series scopes, we do the decoding in hardware inside the ASIC. So very quick, all that good stuff. I'm going to go ahead and turn on a bus decode. So I'm going to click the bus button and select myself a serial bus, and then switch our mode to CAN. And there we go. We are decoding. If I do a single shot and zoom in, we can go ahead and see that time-aligned decode trace here on the bottom of the screen, which is pretty great. So the buses we support include CAN, LIN, I2C, R232, and SPI. And you may be asking, how do I do a SPI decode with only 2 channels? Well, it's kind of a neat trick, actually. We've been lying to you a bit. It's not quite a 2-channel product. We do have a 3rd channel here, this external trigger, which can be turned on to be the equivalent of a digital channel that we can use. So I can actually turn that on right here. And you can see there's a trace on the screen. Now there's no signal, so it's a flat line. But I can use this to do 3-channel SPI measurements. So pretty neat stuff. Now what I am going to do here is show you also one last great thing here, which is an advanced trigger capability. So if I go into our trigger menu, I can switch our trigger mode to normal and type to a CAN trigger. And we can trigger on some pretty advanced things here with the serial bus package. So a lot of power in a pretty small package here. With that, I think we're going to pass it on to the next demo. So thanks. I'll get back to the comment section.
Yeah, so
I'll get out of you here.
serial decoding is all done right on the ASIC.
Yep.
It's the same triggering you get on our tens of thousands of dollars 6000X series scope ported into the 1000X. One spec I didn't talk about earlier in the high-level overview, and it's a spec that everyone was asking about leading up to this. What does this thing cost? So what's our starting price for the 1000X series scopes?
Yeah, so it starts at $449 US. If you want to upgrade to a waveform generator model, extra $200 US. And if you want either of the serial decodes, that'll be $150.
So this is the lowest cost oscilloscope that Keysight has ever made. That's why we're partying. We're pretty pumped about it. So thanks for coming out, Mike.
Cool.
Who do we have next? Melissa, oh, you guys all know Melissa, come on out. If you've been on our YouTube channel, you know that Melissa works a lot with the 9000 series, S-series Infinium scopes, rather. So what are you going to show off on this 1000X, which you don't get to work with very often, right?
Yeah, this is a new thing for me to work with the Infinivision oscilloscopes, but I'm really excited about the 1000X. And particularly, I'm excited about the segmented memory capabilities on this oscilloscope. So segmented memory is really useful when you have a signal that has some interesting information followed by a lot of dead time, or when you're just looking for one part of the signal that you want to see over time. So it allows you to make the most out of the oscilloscope's memory. So for example, let's say this is our signal. So if we set, let's say, a trigger point on the rising edge, with a standard single acquisition, we would get a frame that looks something like this. And you can see we've captured the interesting parts of the signal, but we've also captured a bunch of the dead time that we don't really care about. So if we use segmented memory, we're going to only acquire waveform data around the trigger condition that we've set. So with segmented memory, instead of getting a large frame like this, we'll get a bunch of small frames just around the parts of the signal that interest us. So we get a bunch of frames like this. So this, as you can imagine, is perfect for a situation like serial bus where we're decoding a signal. So let's take a look. How convenient. So let's look at the setup that Mike left us. I think he left us triggering on an error in the CAN bus. So if segmented memory works the way we think it will, we'll get a bunch of captures of these error packets. So how we do this on the scope, we'll go to Acquire, then we'll choose Segmented, and then we can crank up the number of segments. On this scope, you get up to 50 segments, so we'll go ahead and set that. And then to run it, we'll go ahead and select Segmented. So it's running the segments. And now we have 50 segments that we can scroll through. So just like that, you can see we have 50 segments, and you can see how the error packets change over time.
So let's go to the last packet. How many segments did we capture? We captured 50. And how much time did it take to capture all of those 50 segments?
It looks like we got about 5 seconds, 4.9 seconds.
4.9 seconds. So you were able to capture with segmented memory 5 seconds of just errors on your CAN bus. We were able to ignore all the other packets we didn't care about and got right to the heart of the issue on our CAN bus. So segmented memory is a great way to extend your memory, like you were talking about.
Exactly.
Thanks, Melissa. If you want to see some of Melissa's other videos, check out the Keysight Oscilloscopes YouTube channel. There's a playlist where she talks about some more advanced stuff on the S-Series scope. So thank you, Melissa. Up next, we have Boone Campbell. So come on out, Boone. Boone, you just got back from the show, right?
Yeah.
You were telling me this earlier.
I went to the show.
Yeah, do you want to tell me what show you're at?
The gun show.
The gun show. All right. So Boone started with Keysight in the mid 2000s, working on supply chain stuff, and has since transitioned into working with scopes.
Right.
So what do you have for us, Boone?
Well, I'm going to talk about two scope functionalities: the hardware integrated DVM, digital voltmeter, and the frequency counter. So
Awesome.
Right now, for a limited time, the DVM it comes free. It's usually an option, but for a limited time with these scopes, it comes included. And the
DVM is digital voltmeter.
Digital voltmeter, and the frequency counter comes is standard.
Standard. Yep. And it's
the good,
tell
the
us
good thing
that.
about this for the DVM in the lab, a technician or engineer doesn't need a DVM. They can read AC, ACRMS, DC, peak to peak, and they don't need a DVM. Using the probe to do the measurement. And on the frequency counter, it's kind of nice because you can see the waveform and glitches and all that, but you can also measure the frequency at the same time.
And it uses one of the input channels from the scope, and that's actually independent of your acquisition system, so how it's capturing and displaying data. So you can go around and debug a signal with a probe on channel 1 and have the DVM running on channel 1, and that'll run on a separate acquisition system, so you're going to get accurate auto-scaled measurements throughout time, regardless of how your scope settings are. So I think you're about to show me that. If I stole your thunder there,
You
I'm
stole
sorry.
my thunder. It's an independent integrated hardware block, and it's not tied to the acquisition. So if we look here, put my spectacles on.
I'm going to probably start from a default setup here,
Default setup.
and then a good old auto-scale.
Okay.
Possibly my favorite button on the scope is the auto.
Now, the standard scope you can see is it's going to measure here the, here we go, analyze, and then just hit digital. So it's measuring the voltage here, DC, and also we can go to source, frequency, and then source.
So you can run it on channel 1 or channel 2, and you can do a number of different DVM measurements on those channels. So a quick side note on the GUI, whatever button has that little yellow arrow is what button is controlled by the entry node. So if you didn't know that, now you know.
Right, and it's you can toggle back and forth either on screen or here in the corner from either your DC, AC, your DVM measurement, or your frequency. And if I change the time base now, you can see that I'm outside the range where a normal scope would be able to read, because they don't have enough rising edges to calculate the frequency.
Because the measurements happen based on the screen data.
Right, and in this case, the counter, the hardware counter, is still measuring the frequency. So that's a good thing about this as you're searching for some kind of glitch or something. You're still getting like 200 measurements a second on this counter.
It's a pretty cool technology. Yeah. We actually have a patent on how that operates. Someone in the room behind me has that patent. It's a really cool thing. It's really useful because it doesn't really take away from your usage of the scope. Whatever you're doing, it just kind of runs in the background and gives you that measurement.
Yeah.
Thanks, Boone.
Thank you.
Appreciate it. Up next, we have Josh Olson. Josh is the newest member of the Scopes team. And what are you here to tell us about?
I'm going to talk about one of the features that excited me most about this scope is actually just as simple as the help menus. So this is kind of from a standpoint of usability, ease of access in the scope. So let's say you're new to oscilloscopes. You look at this box and you say, I don't really know what any of these buttons do. So what we can do, initially what we have here is the standard help menu. So what this will do is this will give you just a basic idea of what I'll talk about in a moment, the extended help, but you also have the getting started option and the about the oscilloscope option that are both soft keys in here. So getting started will give you just the best intro to using the scope. It'll give you everything you need to just get going with how you can just doing zooming in and all the other basic maneuvering on the scope. But what I think is a lot cooler is from anywhere on the scope, with any of these buttons, including all the soft keys, you can push and hold the button, and you'll get a pop-up of a specific help menu for that button. And what extends this even cooler is if you go into measurements, we've got all these different types of measurements. So let's go, for example, to overshoot. So I'm going to touch and hold on the soft key, and it gives us not only the math behind it, but we get an actual signal diagram that shows us exactly how it's measuring the overshoot and where that information is coming from, which I think is a really, really useful tool for just understanding exactly how the oscilloscope is operating and how to use it.
Yeah, I honestly use the help menus on a semi-regular basis even still. Every button, every menu item on the scope has a help menu built in. You just have to long press the button or knob. It's not just for beginners, so it's obviously makes sense. So Josh, is getting to know scopes a little better. He has a double E degree, but coming in to the scopes group, we obviously, the level of scope knowledge is a little higher. Right. So ramping up into that, the help menus were really helpful. Absolutely. For him, and they're still helpful for me on some of the more advanced features of like, how is that made again? The button really is helpful. Right. So thanks for coming out, Josh. Up next, we have Jae-Young. And Jae-Young, when did you start with HP, I guess? It was HP and Agilent Keysight.
In 1990, I guess.
1990. Yeah. So Jae-Young has been with HP, Agilent, Keysight for quite a while, and he is our probing expert. So why don't you expound on that a little bit?
Sure, yeah. Well, thanks. Hello, everyone. So along with this nice new little puppy, we are introducing a new passive probe that looks like this. So when you buy a scope, then it'll come with one passive probe for each channel. So, and there's no rocket science in it, so it's a passive probe. But the new one that we developed, I just want to highlight a few cool things. This is a very robust design. You see that it's pretty nice, and the hook tips and ground
we
clips.
Took some extra effort to make sure we get, passive probes. They take a beating sometimes, so we wanted to make sure they were extra strong.
Yes.
These brand new probes that we're announcing today, they ship with the scope.
Yes.
We made sure they were, extra robust.
Yeah.
There.
And it also comes with, I don't know if you can see, there's a little
why don't you hold it right in front
ground.
of the scope here?
Yes, okay. Yeah.
And we can switch over to that. Little ground pin spring.
Yeah. That allows you to make measurement with low inductive loading. And the other thing I want to highlight is when you look at the probe, then on the side there's a button here that allows you to toggle between 10:1 and 1:1 attenuation ratio. So let me show you what it looked like.
So this is a switchable 10:1, 1:1 probe, and Jae-Young's going to tell us a little bit about
so
why
as you switch this. Oops, maybe I'm doing it wrong.
As Jae-Young's getting his demo set up here, Jae-Young will also be back. We're having daily videos in Scope Month. We're going to include a scope tip for beginners, intermediate people, and advanced scope users in every scope video. So Jae-Young will definitely be back. He'll talk a little more about that ground pin and some other probing stuff for us. I'm actually really excited to have that happen.
And most passive probe, a typical standard passive probe will come standard with 10:1 attenuation ratio. So meaning that if you have like certain voltage input to the scope, a probe, then it is attenuated by a factor of 10, or the 1/10 of the signal is coming into the scope. So that allows you to look at relatively large signals. But with 1:1 attenuation, the signal is come straight through the probe to the input of the scope. And it doesn't attenuate at all. So it's a really good probe measurement tool if you have a need to look at very low, small signals, such as DC output of a power supply. And so with single probe, you get both the benefits of 10:1 or 1:1 attenuation ratio.
Yeah, so like you said, 1:1 is great for low-level signals. 10:1 is great for higher higher level signals, I
Yes.
guess. Also, there's an article out on electronic design that and probing guide that Jae-Young wrote on K.com or Keysight.com. You can go check that out for a little more details into why you'd use 1-to-1, why you'd use 10-to-1, why we even have that difference in the first place. So thank you, Jae-Young.
Yeah, thanks.
Appreciate you.
Yeah.
Who do we have next? We have Erin. Erin is the product manager for the 1000X series. You might have seen her on our webcast series. She did one of the intros. So Erin, what are you going to show off today?
Today I am going to show you the WaveGen capability along with the FFT. So let's go ahead and take a look at the scope.
So she's going to use the built-in, while you're setting up, Erin, she's going to use the built-in function generator. All of the G models, like I said, have a built-in 20 megahertz function generator, just like the 2, 3, 4, and 6000X series scopes. So she's going to set up a signal using that. It's another live demo signal.
So if we go ahead and look at the scope now, we can see I am just hooked up to the WaveGen output right here, and I turned on the WaveGen functionality. I'm actually going to do a default setup really quick and go back into the WaveGen. So you can see here all of the different waveforms that you can output. There's 6 different waveforms that you can choose from. Right now I'm just outputting a 1 megahertz sine wave. If I go into the settings, we can take a look at some of the other parameters that can be changed. You can add noise to your signal to stress test your design. You can add frequency modulation, amplitude modulation, or FSK. So I added frequency modulation to this signal. And now we can actually use the scope to go in and look at the frequency components of that signal in the time domain. So I can actually press the FFT button on the front panel, that's the fast Fourier transform. So when I press that button, it's actually going to convert the signal in the time domain to the frequency domain so that we can view the frequency components
And let's
on
drop
the
our
screen.
waveform intensity just a little bit. It looks clear from here, but on the screen I see that it's a little tricky.
Thanks, Daniel. And I'm just going to center that around that 1 megahertz signal I'm outputting from the WaveGen. And then I can drop that span down to about 50 kilohertz. And now we can see here the frequency components of that signal I'm outputting from the WaveGen. So we can see that 1 megahertz carrier signal in the center there with the modulation along the outside.
Awesome. Thank you, Erin. So
Thanks,
the WaveGen does built-in FM, AM, and FSK modulation.
Yes.
So that's all built in, included with the WaveGen.
Yes, it is.
I promised I was going to put you on the spot, so I'm going to put you
Oh,
on the spot.
good. Okay.
The 1000X is a 6-in-1 tool.
Yes.
What are the
it
6-in-1?
is. Okay, this is an easy one. So with the 6-in-1, we get a professional level oscilloscope. We get the frequency counter, the digital voltmeter, the frequency response analysis Bode plot, the FRA that Johnny showed off, the built-in waveform generator, and I'm forgetting one.
Is it the digital channel?
Oh, yes, sorry, the protocol
Okay.
decode. So it has the serial protocol decode
protocol
inside as well. So it's protocol analyzer.
Awesome. Thank you.
Awesome. Thanks, Daniel.
So there's obviously much more we could show on the 1000X. We are going to move on to the part that I know you guys have been waiting for. Real quick, I'll also say we have a built-in mass testing. You may have seen it when Johnny hit analyze. That's built into the DSOX models. And we also have one more that I don't remember what I was going to say. So you can check our website, check our YouTube channel, check the later videos. I'm sure we'll cover it then. So let's get to the good part. Who wants to win a scope? So obviously, I was waiting for cheers from behind me, but they can't hear me because it's lagged. So we're going to now go ahead and do the drawing for the scope. So if we could pan the camera over to my computer, I'm going to pull up our drawing tool, and we are confident that this tool is random. I will personally vet every winner and make sure there's no signs of them trying to gain unfair advantage, but I'm confident that these entries are random. We are going to give away 5 1000X series scopes. I'm going to refresh the page. So if you went to scopemonth.com and entered before right now, you will be entered in this drawing. I'm going to hit make sure all those entries are approved, and we are going to draw 5 winners. So let me pull that up. Number of hit enter, and give me just one moment. And we are going to have 5 lucky winners. We're giving away 5 scopes every weekday as part of Scope Month. And you remember last year we did it on the weekends. I don't want to get up on Saturday morning. As much as I love giving away scopes, we're going to do it weekdays this year. You can still enter once per day on the weekends. So we have 5 winners. Winner number 1 is Ryan Eloff. Number 2, Ristina Ristova. Number 3, Nick Depinet. Number 4, Robert Esmond. And number 5, Ricardo Coati. Congratulations, you 5 have won a 1000 X Series scope. We only have 120 more to give away, so make sure you tune back in. Congratulations, there's the delay. So good job, everybody, thank you. So now we're gonna do some live QA, so I'm gonna pull up my YouTube stream here. Mike has been gracious enough to check the stream as we've been going to check out some of the other ones. So question number 1, how many digits is the DMM? It is 3.5 digits. Yeah, someone says probing expert in there. No, we're not doing any QA. I've been told to cut the QA. So thank you for tuning in to day 1 of Scope Month. Come back tomorrow. We're going to give away 5 more scopes. We'll have another scope tip. And on behalf of Keysight Oscilloscopes and the Keysight Colorado Springs division, thank you for joining us. We'll see you later.